Okay, so the stats sample assessment result. The first question is just this, which turns out to be a goodness of fit test. Okay, so you have a read. Jeremy has this belief that drivers are equally likely to record speeding on any day of the week, and he wants to test this. Now, therefore, I've just copied from the mark scheme your hypotheses. Okay? And your hypothesis, yes, we're testing Jeremy's belief, but we need to put what Jeremy's belief is in the hypotheses. So literally quote the question back at the examiner. Now our null hypothesis for a goodness of fit is that the model we are trying to fit does fit the data. So we are trying to test that they are equally likely to be reported speeding, and the alternative is that it doesn't fit the data, so they are not equally likely to be recorded speeding. Right, they did condone it if you wrote about the discrete uniform distribution, but really they wanted in context using the words they put in the question. So then to carry out our chi-squared, we need to work out our expected values, which we usually denote with E. Now you should put these obviously in your actual answer. It's just easy in your answer space. And then you just write them in there. Now to work that out, I worked out the total, because we weren't actually given that, which was 245, and then just divides it by 7 because there are 7 days in my table. Right, this way you should have a proper table, because then you want to work out for your chi-squared your observed minus your expected divided by 4 squared divided by your expected. Okay, so you should have Sunday, Monday, Tuesday, Wednesday. Okay, so for example, for Sunday, which obviously going to turn out to be 0, but our observed value is 35, our expected value is 35, square that, divide that by expected, which is 35, obviously that's going to be 0. For Monday, we'll do our observed was 30, our expected is 35, squared divided by 35. And if you've got a graphical calculator, you can get your calculator in your stats mode to generate all these for you. If you go to a chi-squared goodness of fit test and set up some lists, and you can look that up in your calculator manual. Okay, so they would you might see called the contributions. Okay. Now, then our chi-squared test value is the sum of all of those, which again you get your calculator to help you work out, which is 13.714. Right, so we found our test statistic. We're going to need something to compare that with. In order to do that, we need to know our degrees of freedom. Now, in this case, we've got 7 days of the week, and our totals were fixed. Okay, so the only thing we've relied on is the fact that there is a total of 245 bits of data. So we subtract 1, which gives us 6 degrees of freedom, and then either using chi-squared tables, or in your calculator you can do an inverse chi for our significance level with 6 degrees of freedom. So our significance level is 5%, and they're always one-tailed. So we come up 5%. And then your critical value is 12.592. Well, what can we say from that? Well, we should show that we compared those two numbers. So our test value is greater than our critical value. So 13.714 is greater than that value. And this means, okay, so rough chi-squared distribution, there's our critical value, and this is where our test stat is. That is in the critical region. So if we are greater than that, we're in the critical region. If we're in the critical region, we're going to reject H0. Now, the easy way to them like this is it needs to be back in context. Now, in context, what are we doing? We're rejecting Jeremy's belief. Okay? So, you should never be 100% confident when we're doing hypothesis tests, because there is the possibility that there's a mistake, but there is significant evidence to reject Jeremy's belief. If you really want to cover all bases, you could put Jeremy's belief that drivers are equally likely to be recorded speeding on any day of the week. They usually do, whereas the hypotheses have exactly what we are testing. In your conclusion, they like you to talk about if somebody's believed something, is their belief true or false?